Hello everybody. Today's lesson we are going to once again be looking at graphing. Now remember what we told you. Don't get too slack when it comes to graphing. Yes, this unit requires a lot of graphing. Okay. Our lesson for today, we're going to focus on graphing standard form linear equations, and we're going to change them into slope-intercept form. Okay, make it a little bit easier on us to graph. I'm going to show you what that means. Now, before we even begin, go right into the whole graphing aspect, let me just quickly review to you what is the difference between standard form and slope-intercept form. So, if you have something in standard form, okay, it's going to look like the following. Some number with x, so I'm just going to call it a for right now, okay, plus some number with y, I'll call that b, okay, and this is going to be equal to another number, c. Okay? So this is standard form. And our mission today is to take something in standard form and turn it into something that's in slope-intercept form. So, again, what is slope-intercept form? Well, we just covered that in the last webinar. But slope-intercept form is the following, where it is y equals mx plus b. Okay? Again, where m is our slope and b is our y-intercept. Okay? And at this stage, you have so many tools in that toolbox in order to graph. We can graph either making our homemade tables. We can graph using the x and y intercepts and make a quick graph that way. Or you can graph using the two vital pieces of a line, the slope and the y-intercept. The choices are limitless, the choices are up to you, and you decide what's more comfortable for you. Okay? But for today, I'm going to focus on more what we did in the webinar, which is graphing using the slope and the y-intercept. But the catch is going to be for today, what if I give an equation that's not already starting in y equals form? How do we do that? Okay? So, to convert from standard form, and I'm just going to abbreviate here, SF, standard form, to slope-intercept form. I'm going to use SI here just for consistency here. Standard form, slope-intercept form. And I always just teach this in two steps. One step being we want to isolate the y term. Remember that number, that by, that y, we want to get that completely alone by itself. Okay? And then two, we want to divide everything by the y term. Okay, so essentially, we are getting the y by itself. Because once y is by itself, then we can go ahead and graph using slope and intercepts, the y-intercept that is. Okay? So two steps. Isolate the y term and divide everything by that y term. Therefore, y is by itself. Okay? So let me show you an example. So we have here x plus y equals 3. Now, obviously, this isn't. I can't automatically take the slope from this or the y-intercept and start plotting. It's not in the correct format. Okay? So, two steps. Is the y, first of all, by itself? No. X is over here with it. That needs to get out of there. So, if I want y all by itself, I physically need to take x and I need to move it to the other side of the equal sign. And whenever you take something and directly move it across an equal sign, it's almost like it goes through a force field, and it changes its sign. So this x, when I move it, ready, watch this. Arrow. Okay, that arrow signifies that it changes signs. So I'm going to subtract x from both sides. Notice how the sign has changed. And I have now y is equal to, now, remember, we're trying to get this in slope-intercept form. Y equals some number with x plus b. And no, it looks like we would write 3 minus x. I always write the x term first because I'm really comfortable knowing that the slope is in front of the x term when it's y equals. So I'm going to say that this is negative x plus 3. Okay? Now the second step doesn't really apply here, meaning to divide everything by the number in front of y. If this was a 2y, then I would divide everything out by a 2. But essentially, I'm ready to graph. This is good to go. And one quick reminder, what number is in front of this x here? I only see a negative sign. Right, there's actually a 1 right here, so make sure that if you need to fill that in, fill that in. If it's understood for you already, then it's understood. Okay, so we're going to graph this using the techniques we learned in the webinar yesterday. So, again, this is what we're graphing. We're graphing y equals negative 1x plus 3. Okay, remember, where are you going to start? You start by graphing the y-intercept, and the y-intercept lives on the y-axis. Okay, so start here. So I'm going to plot a positive 3 on the y-axis. Okay, and now I have to decide, am I going to go up or down depending on what the slope is. The slope in this case is negative. I know ultimately my line should be going downhill. Okay, that should be a key indicator for when I'm graphing this if I'm doing it correctly. The rise is going to be negative 1, and the run is actually over a 1. Okay, so starting from right here, I'm going to go down 1 unit and then to the right 1 unit. Down 1 unit to the right 1 unit. And why am I moving to the right? Because the 1 here is positive. Okay, 1 is negative, that's why I'm going down. The 1 on the bottom is positive, so that's why I'm going to the right. Remember, rise over the run. Okay, and this goes on forever. Lines go on forever. If I want to, I can just go down 1 over 1, down 1 over 1, down 1 over 1, until you have enough points to actually see a clear, concise line. I think that's plenty. We're going to go ahead and draw our line. Remember, lines go to infinity and beyond on both sides. So that's why we put these little arrows here. So again, it's important that you remember those. Okay? So, one more recap here. Start with the y-intercept, which was a positive 3. I plotted that. And then my slope was negative 1 over 1. So I went down 1, right 1, down 1, right 1, down 1, right 1. And I kept following that pattern, okay, until it formed a line. Okay? Let's look at another example. Put that off to the side. All right. A little bit more intricate, but nevertheless, nothing that we can't handle. 2x plus 3y equals 9. So, first things first, I need to isolate the y. I'm trying to take this equation that's in standard form and put it into slope-intercept form. Okay, so what I'm going to do here is, to physically move the 2x to the other side, I'm going to subtract it. So, subtract 2x. And remember the rules of an equation. What you do to one side, you have to do all the way to the other side. Minus 2x. This cancels out. So I'm left with 3y is equal to, remember I write the x term first, negative 2x plus 9. Okay. Then from here, step number 2 actually does apply now. Step number 2 says to divide everything by the y term. Well, what number here is in front of y? It's a positive 3. So I'm going to divide everything by a positive 3. Okay? By doing so, the y is now by itself because the 3's cancel out. And I'm left with y is equal to negative 2/3 x. And do you agree that 9 divided by 3 is just a positive 3? Just simplifying that down. Okay? So what's the slope of this line? It's negative 2/3. What's the 3? Right, it's the y-intercept. You're good to go. You're ready to graph. You have both pieces of the puzzle. Okay? So let's go ahead and graph that on our grid. Again, y is equal to negative 2/3 x plus 3. Okay, so I'm going to start at positive 3 on the y-axis. So there it is. Okay, and my slope here is still negative. Okay, so my line should definitely still go downhill. But the question is, how far should my line go downhill? Well, from the y-intercept, I should be going down 2 units and to the right 3. Rise over run. Okay, do not run and then rise. You're rising